precipitation develops in clouds, and clouds are formed when water vapour in the atmosphere cools and condenses. As the water vapour condenses, it forms droplets, and if the cloud develops within or moves into a part of the atmosphere that is below freezing, then the droplets form ice crystals. The cooling process which first forms clouds can happen in many different ways. Air may be forced to rise along a warm front, and as it cools, deep layers of clouds can develop, sometimes reaching many thousands of metres all the way down to ground level. Air may also be forced to rise as a cold front approaches. In this instance, a wedge of cold, dense air pushes under the warm, moist air ahead of it, lifting it. Weather fronts tend to bring generally cloudy skies with relatively long spells of rain or drizzle, or sleet and snow at colder times of year. And finally, air may be forced to rise simply because it's heated by the Earth's surface and it convects. This is what we often see on a summer's day, with cumulus clouds building up and sometimes developing into towering cumulonimbus clouds. Then we can get very heavy rain and even hail. Let's look first at rain and drizzle. The only real difference between rain and drizzle is the size of the droplets. Drizzle is composed of very small droplets, 0.5 millimetre or less in diameter. The tiny droplets that fall from the cloud itself merge together or coalesce until the droplet size becomes large enough to fall from the cloud under its own weight. Even though drizzle is made up of small droplets, it can still produce some very poor weather. Heavy drizzle can seriously reduce visibility because the droplets are small and close together. In tropical climates, where deep clouds develop in warm air, this coalescing of droplets can produce quite heavy rain, but in our latitudes, anything more serious than drizzle usually starts off as ice crystals high in the atmosphere. When clouds build in air that's below freezing, we often get a mixture of ice crystals and supercooled water droplets. That is water which is just below freezing but hasn't yet turned to ice. It is this mix of ice crystals and supercooled droplets that is really the key to understanding how most precipitation forms. The ice crystals are able to grow rapidly where there is supercooled water nearby, because as soon as the supercooled water makes contact with the ice crystal, it immediately freezes. Then, as the crystals drift through the cloud, they connect with other ice crystals in a process called aggregation, and large snowflakes are formed. This process of aggregation can take place in any fairly deep cloud, whether it's formed in layers along a weather front or by the convective bubbling up process. If the air between the base of the cloud and the ground is no warmer than 2 degrees Celsius, then the snowflakes reach the ground intact. In warmer conditions, when the air beneath the cloud is above 2 degrees Celsius, then the snowflakes will melt and arrive on the ground as raindrops. This is the way in which almost all significant rain is produced in our latitudes. It starts as snow, but melts before it reaches the ground. The most energetic cloud types, and the ones that can produce really heavy rain, are driven by strong convection. As the air cools, the water vapour condenses into water droplets, forming clouds. As the cloud grows up through the atmosphere, it will soon pass the freezing level, and water droplets within the cloud will freeze and form ice crystals. That is called glaciation, and an anvil shape is typical of cumulonimbus or thunderhead